Hello and welcome to Astronoscope Workshops. I'm just been doing some bit of research and development, which sounds very posh, but I've been a long time member of a group on Yahoo for people interested in astronomical spectrography. Taking spectra of stars and any sort of any object in the sky, really, and of course our nearest star, the Sun, is very interesting and reveals all sorts of information about itself using spectra, looking at things like the chemistry of the Sun and how things how things are affected on Earth, and there's a lot of interest in space weather and the rest. One of the things that is detectable, although difficult to actually measure and detect, are the disturbances or perturbances in the magnetic field of the Sun. But by detecting the magnetic flux disturbances, you can basically do seismography and a variety of other techniques on the Sun. There started a conversation on the forum, on the Yahoo forum, spectrography forum, about the manufacturing of very high resolution spectrographs. And one of the key components of a very high resolution spectrograph is the way that you manipulate the light as it comes into the instrument. In order to get really high resolution, it's necessary to have a very, very thin strip of light coming from whatever it is, the object that you're observing, in this case the Sun. And in fact, these instruments are called spectroheliograms or spectroheliographs, and they are capable of imaging the Sun using this very high resolution technique in all sorts of different wavelengths of light. So you can see the Sun in not only just white light or particularly coloured light, but in very, very specific, very, very narrow bands of light which represent some of the elements like hydrogen and sodium and such like. Now, the slit thickness is very critical, and amateur spectroscopists quite often struggle to make slits which are very good quality, and obviously they need to be the slit needs to be very thin as well. So I decided to have a look at the making and developing and fabricating of the slits, the blades for the slits, and also the slit adjustments, and to try and make them feasible with very basic tools. Admittedly, I have got some relatively fancy engineering tools, and that does help in some ways. However, I think ultimately, once I've done this R&D, I'm going to try and render it down into something that people can make it pretty much on their kitchen tables, or I'm hoping so. Now, it's possible that along the way I may end up over-engineering some of this, but I'm doing that for my own means because I'd quite like to make a decent high-resolution spectroscope and maybe even a spectroheliograph. So I have been using quite a few of these toys. My Olympus microscope, which is a great tool for this sort of thing because it allows you to see surface finish, and so it's very useful actually when you're doing things like sharpening lathe tools and drill points and things, and you want to get really finely honed edges on them. Looking at them under a microscope like this can really help enormously. The other thing I've been using quite a bit is my taser comparator. I've got a taser electronic comparator. Allows me to measure lengths and internal bores and external measurements to an accuracy of, I think the highest accuracy it'll go down to is something like 0.1 of a micron. But it certainly will measure down to a micron, which is the sort of distances we're talking. These slits need to be parallel and and also the gap needs to be very small, and that allows you to measure those sorts of distances. So it's quite a useful tool if you want to get really high precision. There are a couple of things that need to be done. One is the slits themselves, so learning how to machine and polish the slits so that they have a very, very flat and very, very good finish, because the quality of the edge of the slit has a very big effect on the spectra that you take. And if you get any roughness along the edge of the actual slit blades, you end up with the spectra itself gets these long lines running through it called traversalium, which is a strange word, but you get these lines running across which interfere with your results. So it's important to keep the edge as fine as possible, which I've been doing with using lapping paper or lapping film, 3M lapping film. So we'll have a look at how I did that. I had to make a fixture to hold the blade whilst I was lapping it as well. And then we're going to have a look at the slit adjustment mechanism. So that's again something which I've knocked up on 3D CAD, so we can take a look at that on the computer, and also some of the early components of which I've made. But the intention is to make a adjustable slit which is pretty much where the slit itself is pretty much parallel to within maybe 3 or 4 arc seconds, and be able to be opened all the way from nothing up to maybe 0.5 millimeter or something like that. However, gaps of 2, 3, 4, 5, 6, 7 microns are what are required for spectroheliographs. So the ability to go below 10 microns and also calibrated. So I'm going to be using a micrometer head, a Mitutoyo micrometer head, to actually set accurately the gap of the slit and calibrate it, which I haven't worked out yet how I'm going to do, although I'll probably use a laser and use interferometry to do that. But I'm going to calibrate the actual barrel of the micrometer into microns, slit width microns, so that can be set manually. Ultimately, and this might be a while getting there, we'll have some form of servo or stepper motor which will allow you to set those gaps from software, which will be ultimately really cool. Let's go and have a look at some of making some of the stuff. What we've got here is we've got the block in the vise on some parallels. We've clamped it into the vise. I chopped off another piece of this to put at the under of the vise so that the vise doesn't cockle. So I've got that in nice and straight, and I've given it a good whack with my dead blow hammer so that it's flat down on that underside surface. So I'm just going to square off the end, and then I'll flip it round and we'll do the other end. Let me just yep, so let's just that sort of speed should do it. So we get that down there, lock that off, and let's just touch off from there. Right, so we put a bit of a cut on there. Crap finish is that? I don't know why we're getting such a shy finish. Bloody awful. Let's be blunt. This is going to be a fixture for lapping, and in order to lap a slight, I want to have an angle on the back of the slit blade. So this lapping block is going to have an angle put on it. So because obviously the slit blade is going to be mounted to this whilst it's being lapped, and it's going to give us a little angle. I want about sort of 10-degree angle on there. So I have just set it with this. It's about 10 degrees there. I'm going to do that as a starting point, and just I think that should be okay. So I'm just going to basically mill it down to, in fact, let me just get a marker and sort of show you. I want, obviously it's going to have to be flat all the way across, so it's going to come down to there. So ultimately it'll be sort of down to there like that. So I'm just going to mill that at an angle. I've got that clamped sideways in there. It's up against these parallels. So here we go. Now, as you can see here, I've got a bit of a change of plan. I've put this tool in, which is basically a fly cutter. It is in fact a tool holder from a CNC lathe, which you can pick these up at sale, auto jumbles and auctions, things like that, pretty cheaply. They're really nicely made tools. There's lots of obviously tips available for them, and they are actually designed as lathe tools. However, they work as really nice fly cutters because they've got this offset tool, but it's really rigid and makes a great fly cutter, and I'm getting a lovely finish. I wasn't happy with the end mill, the flatness of the end mill, and I just think this is coming up with a better finish, so that's what we're going to do. So let's just get going. So I'm just putting a little bit of a feed on, and then the feeder in. We seem to be getting a nice parallel cut to the piece. And the nice thing is that it's actually, as you can see, the cutter's the radius of the cutter is longer than the actual length of the piece, which means that I'm not cutting on the back stroke as well. It's just cutting on the front stroke. So let's just continue with this. I'm taking about 10th out at a time, which I don't want to go too hard because obviously it's not the most rigid setup in the world with it clamped on the ends like that. But I couldn't think of another way of holding it that worked. So that's the way I've got it. So here we go, back again. Another 10th now. I'll bring you back when this is a bit nearer. So here we are, we're near the end now. I think I'm just going to take a couple more passes. I'm going to leave sort of 1/2 mil straight edge along that front edge because I think that'll help me with setting it. Let me just I think I'm going to just do a spring pass after this, and I'm going to go all the way across so that I cut on the front and the back of the cutter, so that you get a very flat finish. And I think then I'll just hone that back to a very smooth finish. It's already pretty smooth. I'm pretty impressed. So I'm going to be cutting on the back now. Back stroke coming in now. As you can see, it's just taking a little sliver off there. Which should just help flatten it. Let's just have a look at that, see what that's like. As I can see, you can't see that, can you? So let's see what that's like. Oh, that's lovely. Got nice moyo patterns all over that. and I think that that edge there will, what I'm hoping is that by leaving that little edge, I don't know if you can see that edge, let me just get you in from the other side. You can see that I've actually left this small edge, which I'm hoping will just stop me, because I'm going to polish the back of the slit blade so that it can be used for guiding, and what I don't want to do is mark that up when I clamp it, so I've just left a sort of a 1.5 mil, couple of mil edge there, which will hopefully not clamp onto the edge and therefore leave the reflective edge, but then, you know, obviously have the angle set correctly. So I'm just going to take this out now, and I'm just going to hone it slightly to get all of the tooling marks out so that it's nice and flat. So I'm just going to break these edges. Now one thing that, one little tip is that if you're sort of breaking an edge like that, obviously, you know, you can just do it with a small file and just get that edge off. But one thing that I find, I used to just use emery paper or emery cloth on a lapping plate, but for quick jobs, I buy these are just from Tesco's. These are nail files. My wife buys the emery boards for doing her nails like so, but I find them really handy for when you've just done a small block like this, is that you can just run them across an edge like that and just sort of take the burr off, and also just give them a little chamfer, and they work really well, and you don't have to faff about, and they're really handy just for quick sort of touch-up jobs like that, just for doing a corner or something like that. So yeah, that's quite a good tip, and I use those quite often for that sort of thing. What I'm going to do now, that surface there has got all the tooling marks in it, so I'm actually going to lap that. So I'm going to get my lapping plate out and some memory, and we'll do that next. Okay, so I've got my lapping plate here, and which is just a cheap Chinese cast iron plate, but it's pretty flat, and I'm just going to basically lap the edge of this. As you can see, there are tooling marks on there. I don't know if you can actually see those. Let me just see what you're looking at. If I can get some decent light on there, you might be able to see it. But there are some tooling marks on there. So just holding it flat on here, I'm just going to try and do a sort of figure of 8. Now it's not sticking terribly well on there, so I tend to just put a squirt of WD or something like that, which tends to help it stick down. And I might just do, because it's aluminium, WD is a good sort of general purpose lubricant for that, so I wet that slightly as well, and then it's just a case of figure of 8s like that, until you can see that it's making a sort of paste in there now. So you just need a nice cloth, and occasionally wipe it and just check it. No, the marks are still there. This is 800 grade. I might go up a grade for a while just to see how we get on. That's taking quite a while, so I'm going to take that 800 off. I'm just going to start with something a bit coarser. Let's just get a bit wet on here, and let's see if we can get those marks off. Right, this should do it a bit quicker. I'm not entirely sure why you do figure of 8, but everybody who laps does, so who am I to argue? Okay, I think we've pretty much got all the machining marks off there now. Yep, I would say we've got all the machining marks off there now, so I can go change grades, go back to my let's clean all this up again, make sure that we've got none of the bigger grit on there. Same on the I'm just going to use a bit of brake cleaner on here just to help get the grit off. Actually, new cloth. You go through a lot of cloth slapping because you should never contaminate one cloth with the coarser grit. So a bit more of that on there to make that hole. That's good. A bit more of this on, and let's work our way through the grades. We should be able to get this nice and smooth now. That's feeling flat. You can feel when it flats because it sucks onto the plate. We've still got a few marks on there. I'll just give it a little light touch up on there. Yeah, that's pretty good. And I'm just going to do that very, very edge there. That looks pretty good to me. Just a little bit more. I'm just going to put my magnifiers on to have a quick look at this. Yeah, that's fine. And that's smooth now. That's nice and smooth. Now that's fine. I mean, there are obviously marks on there, but that piece is perfect for what we're going to use it for, which is for, I'm just going to lap the bottom because the bottom is going to be what rides when we do the lapping of the slit blade. So just going to give that a bit of a flatten. That looks alright to me. That'll do. So that's going to be on the lapping plate there with the slit blade mounted along that edge, and I've got to put some holes in there yet to put a clamp. So we'll clamp the blade, push it down onto the plate, screw the clamps down, and then we're going to lap like this on our lapping paper. We'll start off obviously with these sorts of grades and work our way right down to I've got some, well, this stuff here, this 3M stuff here, I think is about 2,000 or 3,000 grit. I'll work my way. I think I'm going to go right up to about 10,000 grit, which is 1 micron. 20,000 I think is 1 micron. So I've got lapping papers that go right down to 1 micron, and that's what we're going to be using. But that's going to set my angle for the lapping, there you go. Right, I've got what we're going to do is just drill and tap the holes in there which are going to hold the slit blade onto the block, so that for the polishing process. So what I've got here is I've got little verdict test indicator in there, and in order to get this straight, I think I'm about there, but I've got it sort of just not super tight, but just sort of slightly nipped up on there, and then I'm just going to get the get my dial indicator. So set that, a bit of a preload on there, so there's 0 that. I don't know if you can see that okay. Let's just have a look. I think you can. So if I run forward and backwards, see if it's straight. So it's pretty much cock on like that. Let's try it side to side. Right, now that is low and that is high, so we need to probably just knock this end down a bit. Can't actually get in. Bingo. Right, 3-0. That's half a thou. And that's the cock on. That's fine for the holes. This is just so that the holes are straight in the into the face. So within half a thou across the whole, half of the whole of that is pretty straight. So let's take that indicator out and we'll drill some holes. Okay, we've got the edge finder in. We've just got to find the middle of this face. So let's just put that down there. That's about there. Let's there we go. Oops. Hello, Sherbs. Let me just double check that. There we go, that's 0. Okay. The other end. Down to there. Oops. There we are. So midpoint Y. 0 3 2 1 0. And it's 250. And then we want to go to 500. Oops. 500 there. Now that ain't right. Zero. That's the middle. And 250. Oh, that's why. Yeah, it's 250, not 500. There we go. Wake up, Powell. Right, there we go. So, and 2.6. 2.6. There we are. There's 250. Okay, that's done that. That's good. Take that out. That's good. Let's just take that out. You can have a look. There ain't anything else to do on there, I don't think. So let me. So there you go. Ready to take the slit blade and hold them in place, and then all we're going to be doing is on the service plate. This is only 3 micron lapping paper, but I've got some coming which is finer, and then we're just going to basically have this on here like this, and then we'll be running. I'll clean that off, but running that up and down the lapping paper like this, all around the edge, and by by doing so, lapping the very edge of the blade, which is in the holder. So that's next step.